Hi guys, welcome to this set of videos. What we're going to do in this video is continue this discussion about ways of proving the congruence of triangles. Now, what we've talked about so far is we've talked about CP, CTC, which means the corresponding parts of congruent triangles are congruent. But remember, that particular theorem, CP, CTC, requires you to prove 6 things. You have to be able to show that all 3 pairs of corresponding sides of 2 triangles are congruent, and you also have to be able to show that all 3 pairs of corresponding angles of 2 triangles are congruent. What that means is you have to prove 6 things are congruent: 3 sides and 3 angles. So what we've been spending the last couple of sections looking at is shortcuts. Ways that we can get around having to prove that everything is congruent, and instead, what is the bare minimum, what is the minimum number of things that I can show are congruent and know that the triangles are congruent. So just real quick here, a fast list of things we've looked at so far. In previous sections, we looked at the angle side angle theorem, which says if I can show, all right, if I can show that a corresponding pair of angles are congruent, that a corresponding pair of sides, it must be an included side, and another corresponding pair of angles are congruent, I know the triangles are congruent, which means I only need to prove 3 things: 2 corresponding angles, 1 included corresponding side. That's enough to know the triangles must be congruent. From there, we took a look at side, angle, side, which says all I have to do is show that 1 corresponding pair of sides, an included corresponding pair of angles, and another corresponding pair of sides are congruent in 2 triangles, and proving those 3 things is enough to prove the triangles are congruent. Then finally, we looked at SSS. By simply showing that all 3 sides are congruent, you know the triangles must be congruent. And again, what was nice about this was I only have to prove 3 things, as opposed to CP, CTC, which required me to prove 6 things. So here we go. Let's continue with this theme. Another way of proving triangles are congruent. Of course, first, as always, our essential question, right? But we've got this new theorem, AAS, which you guys can certainly figure out what that stands for: angle, angle, side. So let's just jump right into this and see what it's going to look like. We've got a couple of objectives that are really going to be the focus of our learning. These are the things that we're going to talk about together. All of these are things that you need to know or be able to do in order to answer our essential question. So here's how the angle-angle-side theorem works. What you're going to do is, if you can show that 2 angles, and this time a non-included side, please notice the difference. This one also has you showing that 2 angles are congruent, but please notice that it is an included side. It is the side included by the 2 angles. In fact, let me show you. If I draw a portion of a triangle here, there's a triangle. What I would have to show, right, is that 2 angles, maybe this one, and their included side, the side between the 2 angles, are congruent. That's how the angle-side-angle theorem works. What we now are looking at is instead an angle-angle-side congruence theorem, which means that 2 angles and a side that is not between those 2 angles, which is exactly what I've got drawn for you right here. If you can show that angle A and angle D, because they're corresponding angles, if you can show that they're congruent, right? And if I can show that angle C and angle F, again, corresponding angles, if I can show that they're congruent. And then finally, CB, side CB, and side FE, if I can show that non-included sides, those corresponding sides, are congruent, then I have angle-angle-side congruence theorem. Okay, now here's the reason that this theorem works. Here's the reason why this theorem works. It's essentially, if you just real quick look right back up here, the last one we looked at in the previous section was side, side, side. We said if all of the sides of the triangles are congruent, the triangles must be congruent. This one, angle, angle, side, turns out to be an angle, angle, angle theorem. If you can show that all three angles are congruent, the triangles must be congruent. Let me show you how it works. And I know I'm not trying to confuse you. I know it says angle, angle, side, but here's why this is actually the angle, angle, angle theorem. Look at this. If I can show, right here, that these two angles, green, green, those two angles are congruent, and these two angles are congruent, then I know without a doubt that these two angles must also be congruent. And here's the reason why. We talked about this theorem, well actually here, I've got it written right here. The third angle theorem of triangles. We've already talked about this idea, and here's all it simply says. The interior angles, right? The three angles inside of a triangle must sum. They must sum to 180 degrees. They have to. That's a property of triangles. You cannot have a triangle if the three interior angles don't sum to 180 degrees. In fact, if the three interior angles don't sum to 180 degrees, you don't have a triangle, right? That's how the theorem goes. They must sum to 180 degrees. Well, think about it. If these two angles are the same, and I know that, and these two angles are the same, and I know that, and all three angles must sum to 180 degrees, well then I don't have a choice, right? There's no choice here. Check this out. If angle A, oh, sorry, that's my highlighter. If angle A, let's just say hypothetically, if A is equal to 30 and C is equal to 60, right? So if A is 30 and C is 60, well, since A is equal to D, that means that D is also 30. And since C is corresponding to F, that means F is also 60. But now watch this. Look, B and E. Remember, the angles must sum to 180 degrees. I must get 180 degrees. I don't have a choice. That's how the third angle theorem works. They must sum to 180 degrees. Well, 30 and 60 is 90. How do I get to 180? It's gotta be 90 degrees. But the exact same thing is true over here. 30 and 60 sum to 90. How do I get to 180 degrees? E also has to be 90. It has to be. There's no other choice. So if I know two of the angles in corresponding triangles are congruent, then I know, thanks to this theorem, the third angles must also be congruent. They have to be. They have to be. So we're going to call it the angle-angle-side theorem. Really, it's the angle-angle-angle theorem. If you know that two of the angles are congruent, the third set of angles must also be congruent. So let's take a look at how this is going to go in a problem right here. What I've given you is this nice little diagram and a few things about the diagram. So let's go ahead and take a look at what I've told you. First, here's what I've told you. I've told you that AC, so this guy right here, AC, that segment right there, is congruent to EC. EC, that segment right there. So let's go ahead and put that into my diagram. I know that AC and EC are congruent, and those little hash marks tell me that they are congruent. I also tell you that M and N, right, that little symbol there means parallel. They're parallel lines. Okay, well let me put that on here as well. Remember, the way that we show parallel lines is by putting those little arrows right on those lines, and that tells me that they are parallel. So M and N are parallel, and AC and EC are congruent segments. What I want to know is I need you to prove. Can you prove that triangle ABC, and triangle EDC, EDC, can you prove that those are congruent triangles? Okay, great. Well, here's what we're going to do. Just a couple of things. I take a quick look at this, and right away, here's what I notice. Please notice, thanks to vertical angles. Remember, vertical angles says whenever you have intersecting lines, angles opposite each other must be congruent. They have to be. That's what the vertical angles theorem says. So right away, here's what I know. I have a pair of vertical angles right there, which means they must be congruent. So let me put my little arcs right in there. I know that those two angles have to be the same. They have to be. They're vertical angles. The theorem says vertical angles are congruent. Okay, we're off to a great start. Here's what I've got. I've got an angle and I've got a side. I need another angle. Okay, fantastic. Check this out. Let me go ahead and draw this guy in here, right here. I'm just going to extend that line a little bit further for you. And the reason I'm doing it in blue is because I want it to stand out, right? I want you to see this. Okay, there it is in blue. Now, this line right here, right? This goes back to our previous chapter. Please notice, I have two parallel lines. This blue line is a transversal. I have a transversal cutting through two parallel lines. Well, now I go back to all of those properties I learned about angles in transversals and parallel lines. One of those properties was alternate interior angles are congruent. Do I have any alternate interior angles? You bet I do. This angle right here is an interior angle, and this angle right here is its alternate interior angle. So let me go ahead and erase that little blue bar right there that's getting in my way. I know that these two guys right here, this angle and this angle, must be congruent. They have to be, right? It's a transversal cutting through two parallel lines. These are alternating interior angles, and they must be congruent. Well, that's good enough. Angle, angle, side. Angle, angle, side, right? I have the angle, angle, side theorem. So thanks to the angle, angle, side theorem, yes, these triangles are congruent. In fact, let me write that down here real quick for you guys. Alternate interior angles, just to help you see it a little bit better. This guy right here and this guy right here, right? Those are alternating interior angles because I have parallel lines and a transversal. Let's try a couple more. We can go through these next ones a little bit quicker. I think we're kind of getting the hang of it here. So let's go ahead and do that. So here's what I've got. I got a few more diagrams for you. I give you a little bit of information. So here we go. I tell you that angle A and angle D are congruent. Let's go ahead and put that. Angle A right there and angle D are congruent. Fantastic. What else do I tell you? Angle A, angle D are congruent. I want you to prove angle or triangle ABC and BCD are congruent. So I want you to prove the two triangles are congruent. Well, right away, already what I recognize in the diagram, since the information that I gave you, right, angle A and angle D are congruent, and then please look, right there in the diagram, I tell you, right, that's a right angle, and that's a right angle. So I have angle, 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 so I know, right, I've already got two angles. Now, right here, thanks to the reflexive property, I know that these two sides are congruent, right? BC has to be congruent to CB, right? BC, CB, congruent, that's the reflexive property. And so that's enough, right? Right there I have the angle, angle, side theorem. That's all I have to do. As soon as I have two angles and a non-included side. As soon as I can show that those two angles and a non-included side are congruent, I have enough. The angle side theorem. Let's try another one. Here's what it tells me. Angle B and angle D are congruent. So let's put that in there. In fact, actually, look at that. It's already in there. So those two angles are congruent. I tell you that AC, there it is right there, AC is oh, there's a really important word, bisects. Bisects BCD. BCD. So, there we go, right? Remember, a bisector means it splits the angle in half. Splits it right down the middle. So, what does that tell me about these two angles? It tells me they're exactly the same. These guys have to be congruent. They have to be. That's what a bisector does. So because AC is an angle bisector, it's going to split that angle into two equal parts, two equal angles. So those are congruent. And once again, just like above, AC is congruent to CA. It's the reflexive property. It's the exact same line. So I know that this right here is congruent. And so I have angle, side once again. Okay, let's keep going. What do I tell you about this next one? Here's what I tell you. AB and DE are congruent. Congruent, holy cow. That means parallel, and the little arrows are already in there. Great. Here's actually what I'm going to do. Let me extend those lines just a little bit further. It might help us see a little bit better here what we're going to do. There's line AB. There's that line DE, right? Just extend those a little bit further. And then I tell you that CB is congruent to CD. CB, CD. Oh, look, it's already in there. They already put the little hashes in there for you. Okay, great. So that's the information I've given. I want you to prove that the two triangles are congruent. Prove that the triangles are congruent. Well, actually, here we go. Let me draw this line through here. Look at what I've got. We saw this on the previous page. I have a transversal cutting through parallel lines. A transversal cutting through parallel lines. What does that tell me? Well, it tells me lots of things about the angle relationships. The most important one, the one that I'm actually going to use is this. Alternating interior angles are congruent. I have alternating interior angles here and here. And I know alternating interior angles must be congruent. They have to be. So I know those guys are congruent. Then, please notice, I have intersecting lines, which means opposite angles, thanks to the vertical angle theorem, must also be congruent. So I know that those angles are, and right there, boom, we have enough. Angle, side, angle, side. We got it. Angle, side theorem. Okay, guys, that's how this is going to work, right? Yes, we're pulling on theorems we've already learned in previous sections. That's really the theme you're going to see as we go through geometry. We talked about vertical angles earlier. It's showing up again here. We talked about alternate interior angles in a previous section. It's showing up here, right? That stuff's just going to keep following us through geometry as we go through this course. But that's the way math classes really are, right? They just sort of build on prior information and we just keep building on it as we go. This isn't any different. I got one more for you here. I've given you a diagram, and this time what I've asked you to do is which theorem or postulate can be used to prove the triangles are congruent. Select all of the ones that apply, all the ones that will work. So we're going to go ahead and take a look at our diagram here and see what we've got. Well, first of all, I put those nice little right triangle things in there for you, so you know right away, hey, this angle and this angle, those guys are the same. In fact, not only are they the same, they're both 90 degrees. I also tell you that this guy and this guy are the same, so I know that those two angles are congruent. It's right there in the diagram. And I give you these little hash marks to tell you that this side, whatever that side is, and that side, I don't have names for them. I didn't put any letters on these, but whatever, the hash marks are in the diagram, so you know they have to be congruent. Well then, real quick, it just takes a second to look at it, and you guys know, thanks to the reflexive property, we've seen it like 3 or 4 times here already, these two lines are congruent, right? This line, this base of the triangle, is congruent to the base of the other triangle, right? It's the exact same line, so they have to be congruent. So here we go. I take a look at this and I have an angle, side, angle. Well, that is definitely one of my theorems. In fact, it's written right there, angle, side, angle. So that one would work. Angle, side, angle proves angle, side, angle. Those two triangles are congruent. But what else do I have? Well, look, I have side, actually, what do I have? Yes, side, angle, side, right? I know that this side, these two sides are congruent. I know that these two angles, and then of course these sides, so that's side, angle, side. So that one works, side, angle, side, absolutely. What about side, side, side? Side, side, I don't, right, it's not given to me in the diagram. I do not know that this side and this side are congruent. At least it's not told to me. Yes, absolutely, we could go about proving that, but just based on the information given to me in the diagram, just based on that information, I cannot say for sure that I have side, side, side. I can't say that for sure. So we'll not do that one just based on the information given. And then of course this last one, angle, angle, side. Absolutely, look, if I did angle, angle, non-included side. Angle, angle, non-included side. So this one would work as well. Just, again, just based on information given to me in the diagram. Could we prove side, side, side? Yes, absolutely we could. But based on what was given to me in the diagram, those are the 3 that, without doing any work, would be enough to prove that those two triangles are congruent. Alright guys, head on over to the next page of the notes. We'll take a look at a few more problems with proving angle, angle, side theorem and using that to prove triangles are congruent. I'll meet you guys on the next page.